Okay, so today we're going to be looking at the AP test, one of the free response practice problems. Okay, so the thing about the AP exam is that the free response questions, they actually take multiple concepts, okay, that we've done throughout the year and put them together all into one problem. Okay, so after you take the first two sections multiple choice, you get to the free response section. There's 6 problems that you do with multiple parts, usually 3 or 4 parts per problem. Okay, so today we have this one. Okay, one of the things that you have to be able to do is be able to read a chart. So the functions f and g have continuous second derivatives. Okay, the table above gives values of the functions and their derivatives at selected values of x. So remember, for a function to be differentiable, it has to be smooth and continuous. Okay, so they're telling you that f and g have continuous second derivatives. Okay, which means these are the points they all have derivatives at. Okay, so the first thing they ask you is they say let k of x equal g of f of x. Write the equation for the tangent line to the graph at k of k at x equals 2. Okay, so basically, excuse me, this is a tangent line problem. Okay, we've done tangent lines, running tangent lines for a while. Okay, so the first thing I see, I want to write the equation of a tangent line, is to write the equation of the tangent line. The tangent line equation is y minus y1 equals m times x minus x1. So we need to find out x1, y1, and of course the slope. Okay? So x1, that's what they gave us. That's 2. Okay? So we know what x1 is. x1's 2. Now, to find y1, y1 is, well, in this case it's k at 2. Okay, so we come over here, we go, okay, k at 2, that's g of f of 2. So we go, well, what's f of 2? So we come up here to the chart, f of 2, so f of x at 2 is 2. So this is g of 2. Okay, now I'm going to plug 2 into g, so g at 2 is negative 3. So y1 is negative 3. Okay. Next, I need the slope. So I need k prime at 2. So first thing I need to do is find k prime of x. Well, k of x is g of f of x. This is explicitly a function inside of another function. So when I go to take the derivative of this, I have to do chain rule. So k prime, the derivative of the inside, is f prime of x times the derivative of the outside, which is g prime f of x. This is literally the definition of chain rule. Okay? And so there's the derivative. So next I need to find k prime at 2. So f prime 2 times g prime of f at 2. And again, we're going to be using a chart. So f prime at 2. So we come up here, 2. F prime at 2 is negative 2. So this is negative 2 times g prime. And what's f at 2? F at 2 is 2. So this is g prime at 2. So negative 2 times, what's g prime at 2? G prime at 2 is 0. So this is negative 2 times 0, which is 0. So my slope is 0. And now we just plug in. So that means our tangent line equation is y minus -3 equals 0 times x minus 2. And that's your tangent line equation. Or if you simplify, this is going to be 0. This is going to be, therefore, y equals -3. So that's my tangent line equation for k at 2, which means that k has a horizontal tangent. So that means that this is basically, since the slope is 0, we have a maximum or minimum there. Okay? So that's it. So we've taken a bunch of ideas and put them together. So part A has basically chain rule. It has the tangent line equation, and it has the chart that you got to do. So this is 3 different pieces that we've been practicing all put together in one. Okay? All right, part B. Basically is very similar to part A. It says h of x equals f of x, g of x. Find h prime at 2. Well, before I can find h prime at 2, I got to find out, well, what is h prime, period. So we have to take the derivative. So h prime of x. So the derivative of f of x times g of x. I have a function times a function, which means I have to do product rule. So f prime of x times g of x plus f of x times g prime of x. So there's my derivative. Now evaluate h prime at 2. So that's f prime at 2 times g at 2 plus f at 2 times g prime at 2. And then we just go back up to our chart and we look at it. Okay? So what's f prime at 2? So we go f prime at 2 is -2. So this is -2 times g at 2. Go over here, g at 2 is -3. So it's -2 times -3. Plus f at 2. And we come back up here, f at 2 is 2. So this is plus 2 times g prime at 2, which is 0. So this is going to be -6. Plus 0, which is -6. So that's my answer. That is h prime at 2 is -6. Okay? So again, this is basically just product rule. Okay? All right, part C. Evaluate this integral. It's the integral from 2 to 6 of f prime of 1/2 x dx. Okay? So this is actually a basic U-substitution problem. Okay? So I'm going to say that u is 1/2 x, so du equals 1/2 dx. So 2 du equals dx. So here we go. So the integral of f prime of u times 2 du equals, and the 2 is just a constant, so we move that out front, will be 2 f of u. That's the antiderivative part. Okay? Now, I'm also going to change my upper and my lower limits. So u at 2, when I plug in 2, I get 1, and u of 6, when I plug in 6, I get 3. So my new limits are from 1 to 3. So that means I'm going to come over here and evaluate this from 1 to 3. That means this is 2f of 3 minus 2f of 1. So again, we come up here to our chart. F at 3 is 8. f of 2 is negative 6. Sorry, f at 1 is negative 6. So this is 2 times, what is f of 3? 8. 2 times 8 minus 2 times f at 1, which is negative 6. So this is 16 plus 12, which is 28. Okay. Or if you had just left it, if you had done it after, like you had plugged in your u, you could have done it, gotten f, this would have been 2 f of u, and then plugged back in the 1/2 x and evaluated it from 2 to 6, you would have gotten the same thing. Because when you plugged in the 6, it would have been 2 f of 1/2 times 6 minus 2 f of 1/2 times 2. And 1/2 times 2 is a 1, and 1/2 times 6 is 3. You still would have gotten 28. Okay, so you can see this is a problem that is multiple pieces. It has U-substitution, it has a chart, it has antiderivatives. So these free response problems tend to have multiple pieces layered into each part.